Cheng Fluid Systems of Sunnyvale, California would like to introduce you to the Cheng Rotation Vane, or CRV. The Cheng Rotation Vane is the only true solution for post-elbow metering applications. It prevents problematic flow separation in an elbow and removes the need for long meter runs to condition the flow. A steady equilibrium flow distribution is necessary to achieve optimal accuracy from the measurement instrument. All flow meters or measurement instruments are calibrated to respond with accuracy and precision to symmetrical uniform velocity profiles. Such optimal symmetric shapes vary from the parabolic laminar profile to the top hat or flatter turbulent profile. Distortion and separated flow always accompany the flow through an elbow. The constriction in a pipe section caused by the separation regions, as shown in this diagram here. These separation regions on the inside and outside, in turn, generate downstream of the actual elbow section a profile deformation, which can be quite drastic. This deformation is introduced because centrifugal forces create a pressure gradient across the elbow as well as secondary motions. The traditional treatment to deal with this in the metering industry for the deformed, highly turbulent flow leaving an elbow is to use long meter runs to allow viscous forces to reestablish the steady equilibrium flow distribution. For a plain elbow, standard meter runs are up to 30 diameters, depending on the type of fluid. Tubular flow straighteners still require 20 diameters for velocity distribution settling. And when there is no room, oftentimes more expensive flow meters are installed. But even more expensive flow meters can require upstream and downstream metering runs. Whether one is dealing with the orifice meter, the flow nozzle, pitot tubes, vortex meters, turbine meters, or even the Venturi meter, meter runs to dissipate the flow disturbance are still required. Lack of these meter runs and minimizing them still affect accuracy. The traditional treatment is to dissipate the flow disturbance via viscous forces. The solution of the Cheng Rotation Vane, however, is to prevent them from occurring in the first place. The Cheng Rotational Vanes, or CRV, is a set of stationary vanes positioned ahead of the elbow that precisely rotate the flow about the axis to compensate for the rotation through the elbow. The CRV shown here alters the fluid flow by introducing a rigid body rotation that maintains an equal streamline length across the pipe and throughout the elbow, such that the flow profile is preserved. This is a 10-inch CRV. Here, the vane is welded to the pipe stub, which is typically 1 diameter long. The pipe stub, in turn, is welded to the elbow. This elbow in this diagram is a long radius elbow. The vane geometry from the central region to the wall region is generated via computer such that the applied rotation is exactly 180 degrees as the flow goes through the elbow. The flow enters in this plane here and rises out of the top of the screen for this geometry. In this diagram, we can see that the Cheng Rotational Vane acts much as lane staggering does in a high school track running competition. The track is staggered so that the runners can finish the race after having traveled the same distance. Since the fluid particles in a flow must both start and finish parallel to one another, they are rotated by the CRV in the third dimension so that each particle travels the same distance. The particles on the inside of a bend travel around to the outside, and the particles on the outside travel around to the inside. There is relatively no interaction between the particles. The inside particle arrives at the downstream region at the same time as the outside particle. The center line is not rotated at all. Here, we have returned to the flow disturbance introduced by an elbow. The fluid is coming in on the upper right-hand side and going down the screen. The fluid here is air. There is no CRV here. Note the backflow associated with this first velocity profile, 0.25 diameters downstream of the elbow. This deformation, as one moves slowly downstream, will slowly dissipate due to viscous forces. This is the mechanism used by pipe runs to dissipate the flow disturbance and return it to a uniform flow profile for metering applications. With the CRV, however, we have a uniform profile immediately exiting the elbow. Here, one could insert a turbine meter or an orifice meter and get a respectable accuracy out of the device. Essentially, any flow meter could be inserted immediately downstream of an elbow with a CRV inserted before the elbow and still achieve very respectable accuracy. The CRV prevents the flow disturbance from happening instead of removing it after it has already happened. To further visualize this, we have injected dye into a water flow moving from left to right. The picture on the top is seen in a mirror angled 45 degrees over the elbow, which is on the bottom. The bottom view is looking into the elbow. This is the flow separation region on the outside of the bend. And down here is the flow separation region on the inside of the bend. Notice that none of the streamlines pass through these regions. Clearly, there's no CRV inserted before this elbow in this flow. If one is to look downstream after the accelerated region where all the streamlines seem to come together, one will see a great deal of mixing. This is due to the turbulence intensity associated with the flow that pass through the elbow. If one looks at the picture on the bottom of the screen from left to right, one will notice that the streamlines break up due to this high turbulence intensity. But this is not the case with the same flow situation moving from left to right with the CRV as shown here. The flow comes in through here, and you can see that the streamlines are continuous. On the left, it's rotated 180 degrees through the bend and comes out on the right. And on the inside, it's rotated 180 degrees exactly and comes out. There's no rotation after it has passed through the elbow. This is because it's been fighting the secondary forces in the bend. The streamlines are really not broken up as much as they are in the other one. If you look down here, the streamlines are still essentially intact. It's clearly shown in the lower screen. And the separation region on the outer wall, there's a streamline passing right through it, just as there is here on the inner wall. The CRV has shown that it prevents the flow separation as well as the turbulence generation associated with flow through an elbow. The CRV has many benefits to metering. Primary among them are removal of the large-scale turbulence as well as the velocity profile deformation associated with flow through an elbow. The CRV eliminates flow separation, large-scale turbulence, presents uniform flow to known location, and reduces head losses. All of the engineers and salespeople here at Cheng Fluid Systems are looking forward to applying the technology to your application. We are familiar and experienced in both gases and liquids. The CRV is applicable to all elbow geometries, and we can customize our designs from 0.2 inches in diameter up to 6 feet in diameter. We look forward to serving you.